think they caught that. All right, so we are continuing with our applications from yesterday. So yesterday we discovered this new formula, which is really how your savings accounts work, right? So this question feels like they didn't give you enough information, guys. It says, how many years will it take an account to double its value if you collect 4.5% interest? So let's start there. That's a clue. This is our rate. But remind me, I can't write 4.5 in math. What do I write? 0.45. So earlier today, a lot of kids were having trouble with where that number's coming from, and they were doing it wrong and getting a lot of wrong answers. It's just the percentage divided by 100, or you can think about moving the decimal point 2 spaces to the left. Anywho, continue reading, and it says that we are compounding monthly. So that is this new n factor that goes into this formula. So monthly means how many times a year? 12. Good. And the question says how many years? Well, that's the question. We got to do a little math to figure it out. Do you feel like they forgot to tell us something? Yeah. Well, true, but that's what we're finding. What they didn't tell us how much money we're investing. Do you think that's important? I mean, kind of. Turns out it's not important. Because if you invest $1, $10, $100, or $1 million, it's going to take the same amount of time for your money to double. So how much money would you like to invest today?
$4 million.
Okay. I heard 20. That's, oops, not invest. 20 whole dollars. Big spenders, you. All right, so we're going to invest $20. So this is what we're going to use for the principal. So my formula is going to be 20. And then 1 plus the R you guys told me was 0.045. You're going to divide it by n, which since it's monthly, it's 12. And then up in the exponent, that 12 shows up again, times the number of years. But remember, we don't know the number of years, so I'm going to call that x. And remember our work from yesterday. If you are trying to find time, if it's a variable, what part of our calculator do we need to be going to? This has to go to the y1. We're going to use our table. What are you doing? She probably shouldn't sit there. All right, so on your calculator, everybody, get this function typed into y1. I will do that as well. Now, for funsies, can someone invest some other money other than $20? Like, dream big. Go like $100 or something. Well, $4 million might be a little crazy because it's going to do scientific notation. $500? Yeah, choose something other than $20. I just want to prove a point. All right, what was I doing? 20. So somebody, a couple of you, do a different number here besides 20. Oh, okay. Now remember, if you're on an older calculator, you're going to have to use parentheses around this 12x up in the exponent. On the newer calculators, you don't have to do that. But do make sure you have an x there. So we're going to go to our table. And usually on these questions, I was given, like, look for this number. Well, they didn't give me that because I want my money to do what now? I want it to double. So if I invested $20, what target number should I be looking for? $40. So I'm going to scroll down for a while till I find $40 in the Y column. Now, whoever invested $800, what number are you looking for? $1,600. Those of you who invested $100, what are you looking for? $200. But watch what magical thing is about to happen. We all get the answer of 15 to 16 years. So regardless of how much money you invest, it's still going to take 15 to 16 years for that amount of money to double. So you'll be waiting around for a while, is the point. Okay? So, yep. I have some kids who every single time this question comes up, they invest $1. They want to dream big or something. I don't know. And then they're like, where's $2 at? And I'm like, okay. You'll notice on my answer key, I always invest $100 because that's easy to do math on. Because doubling it, tripling it, like, I can do that easy. All right, so the answer here, guys, was 15 to 16 years. So a big task for you today, guys, is because we're using so much technology, You have to know when to use what part of your technology. So why did I use my table on that question? Because I didn't know time. If the question says how much time, that's a dead giveaway. You're supposed to be using your table. Okay? But if they give you time, that means you just flat out use your home screen, the regular calculation screen. All right, so we have a new formula, and none of these formulas need to be memorized. I'll give them to you on the test. This is called the continual interest formula. So we saw some examples yesterday where they collected money like monthly, quarterly, daily. Well, continuously means literally you collect money at every second of every day the whole year. So you would think like, wow, that's going to be amazing. I'm going to make so much money. Turns out no. All right, so this guy, mathematicians call this PERT, like the shampoo, PERT plus PERT. Can you see why we call it PERT? Because it spells PERT. So it's P, still principal, times E to the RT power. E is a number. Like how pi is a number? What's pi? 3.14159, blah, blah, whatever. E is a different number. Can y'all explore the calculator for a moment with me? You can find E a couple of different places. The first place that I see E is right above the division key written in blue. There's a little lowercase e. So use second division and hit enter. That is the number E. So it's called the natural number. We'll learn more about him later on in the chapter. But it's a weird irrational number. The other place that you might see the E is down here on the left side of the calculator above what's called the natural logarithm. Again, we'll talk about that later in the chapter. But you go second natural log, and then it brings up an exponent. So like for our purposes, we're going to be using this one every time because I want to take E and raise it to the RT power. So for now, just stick a 1 in there. Boom, 2.718. All right. So now that we know where to find E, let's talk about this formula. It says you invest $1,000, so there's your principal, at 8%. All right, help me out with the decimal here, guys. What is that as an R decimal? Good, 0.08. And then for 1 year. It's very exciting. T is 1. All right, here's what we're going to type on our calculator, and I'll ask you where in a minute. We're going to type 1,000. And then times E, but you don't have to do a multiplication symbol because it implies that. And then up in his exponent, it's to the 0.08 times 1 in the power. So, do I know time? Yes, so I should be in the home screen of my calculator. So what I'm going to do is type that. I'm going to type 1,000. I'm going to use the E that's over here above the natural log key because it automatically pulls up like the caret exponent position for me, which is nice. And then I type 0.08. Do I really have to type times 1? No, but for the sake of my process, I'm going to do it anyways. How much money y'all got? Yeah, not as much as I thought. I mean, you're getting money all the time, and you only got like, yeah, not a lot of money. It's hardly any more money than that. Remember the questions yesterday? We kept getting like 1,080, 1,082, 1,083. Well, this one is continual, and it's 1,083 and some change. Like, that's pretty lame. So, whatever. It's more. More is more. 1,000. I've lost my number. 1,083 and 28. Okay, very good. So, next question here, very similar. This time we're investing $800. Whoops, that's 800. Continuous interest, so E, 7%. Please write it as a proper decimal of 0.07. And this time it's multiplied by 3 years. So again, home screen on my calculator, this type. 0.07, was it times 3? Okay, thank you. So you have $986.94. So this final question here, how long will it take for an account to triple if it collects 5% continuously? This feels a whole lot like the first question we did today, but because it's compounding continuously, you're going to use that PERT formula that we just used a few times. So, you notice they don't give you what? How much money? So how much money would you like to invest? 100. I like it. So I'm going to invest $100 because I want to. And then we're going to multiply it by e to the r. How do you write that? Good. 0.05. And then times t, which is time. We don't know time, so it's x. Very good. Because I don't know time, where should I be going on my calculator? I should be going to y1. Very good. So get this typed into your calculator. And then our next step is going to be to look at our table. Now, we invested $100 because that's the first answer I got from somebody. So what am I looking for on my table? I'm going to look for $300 because it wants my money to triple this time. Now, if you invested $1, you're looking for $3. If you invested $10, you're looking for $30. And if you invested something weird, I hope you can figure it out. Okay? And again, between 2 years answer is totally fine. You do have to scroll down for quite a bit. Is it 20 something? 21, 22? Yeah. Okay. So, good. Very good. All right. Let's take a peek at, a wildlife endangered species list that's really outdated. This is bad. I should update this question. Okay, so they collected some data from 1972 to 1998, and the number of species on the list can be modeled by that equation. So apparently it's growing continuously. I can tell that because they use the PERT formula. Someone else who knows more math than us created this model. They collected data, and then they did a lot of what you will do in a stats class in the future, and they created a model. So the first question is, what was the number of endangered species in 1972? And all day today I've been having kids who are like, well, I don't know, let me go to my calculator and figure this out. And I feel like that's a little bit of overkill. Can't we just figure that out from the equation? Because if this equation starts in base year 1972, that number in front is the number from 1972. That's the starting value. So all day today, kids were kind of like, I don't understand this. Like, how do you have 119.6 species? And the idea is it's a model, so it's meant to fit the data, and we all know that's not going to be a perfect fit. So there we go. We are not going to graph it. We're going to look at our table. Forget that. But we do need to get this typed in our calculator and figure out what year did your endangered species list hit 1,000. So the question here is when, which means I don't know time, which means I'm going to be on my table. All right, so go to Y1. Please type in 119.6 times E. I can't read that. 0.0917, and then you're going to use X instead of T because of your calculator. And again, guys, you're not going to get an exact answer. You're going to tell me between such and such years. But I need you to look on your table, try to see when it hits about 1,000 over here. About 25 years? 23 to 24? Okay. So, what does that mean for my problem, though? Because it's 23 to 24 years after the model started. So, if this model starts in 1972, and let's just round up to the 24th year. 1996? Y'all weren't even born yet. That's sad. It's a good year. I believe that was the year that Backstreet Boys hit the sound waves, the radio waves, if you will. Backstreet wasn't even back yet. They just were. It's a good joke, Mrs. Abruzzo. Very timely for this generation. All right. So that's going to end the lesson. We're going to turn off the mic in a minute, guys. We're going to work on an applications worksheet. You guys are going to get enough class time here to get done what you need to get done. Number 8, we're going to work through together, though. So if you get to number 8 ahead of me and you're a little confused, then just hang tight.